Hello students, and welcome to section 8-5, Properties of Logarithms. Properties of exponents can be used to develop the following properties of logs. So first, the product property of logs, such that for all positive numbers a, b, and x, where x cannot equal 1, log base x of ab is equal to log base x of a plus log base x of b. If you recall the basic product property of exponents, where we multiply a to the m times a to the n, we simply add exponents, m plus n. This property is similar, except we're using logs and not exponents. The quotient property of logs speaks to for all positive numbers a, b, and x, where x is not equal to 1, log base x of a over b is equal to log base x of a minus log base x of b. And again, similar to the property of exponents of which you are dividing a to the m over a to the n, remember we subtract exponents. In this particular case, we're subtracting, again, it's logarithms that we're subtracting, but there is a connection to be made to the exponent properties, just as we discussed at the beginning. The power property of logs. For any real number p and positive numbers m and b, where b is not equal to 1, log base b of m to the p power. If you were to move the power as a multiplier or a value essentially in front, p times log base b of m is the rewritten version of this. One thing to keep in mind is that you don't necessarily have to start with the expression on the left to get then the expression on the right. In other words, you could start with the expression on the right to then rewrite it as you see in this particular form. So you could go from this version to that, and so on and so forth. You could start with this and move it as you see here, where the number in front now becomes the power. All right, for example, use log base 3 of 28, which is approximately 3.0331, and log base 3 of 4, which is approximately 1.2619. One of the things to keep in mind, and I actually denoted this up above just to rewrite 28 as a product of prime numbers or prime factors, technically 2 times 2 times 7. That's one interpretation of rewriting 28, as is rewriting 4 as its prime factors, 2 times 2. And the reason this would actually help us in the future is because there is a good likelihood in the problems that follow that we're going to rewrite using 28 with these factors and or 4 with those factors. We're going to approximate. So we're going to do the best we can without necessarily needing a calculator on these. And on problem A, to kickstart our process, I'm just going to go ahead and uncover A, and I'll walk you through each respective step here. So to start with, we have log base 3 of 36. So 36 is not obviously what we started off with being provided, 28 and 4 as you see. However, 36 can be written as 9 or 3 squared times 4. Now why would you take 9 in the particular setup here, where again 9 doesn't even exist at the beginning either. 4 does, but 9 doesn't. Well, it turns out that 9 is nice because 3 squared, noting the bases are the same here and here, it will then allow us to use the power property very succinctly, such that log base 3 of 3 squared, because I can take the 2 and move it in front as a power property application, I now have 2 times log base 3 of 3. Log base 3 of 3 is simply 1. 3 to the first is 3, as we know. So simply what you're left with is 2 times 1, of course, 2. Log base 3 of 4, you are provided that. So 1.2619 as you see written in place here. So 2 plus 1.2619, final answer, 3.2619. Now these are approximations, certainly, but you could type this in your graphing calculator, or any calculator, I guess, with log features to be able to check to see that you've done it correctly. And it is roughly that answer. Let's move on to part B. Part B, log base 3 of 7. So some of the techniques that they have used here on this particular problem, as you can see, include taking 7 and writing it as a quotient of 28, which yes, you were given at first, but also 4, of course. So 28 over 4, which is 7. Well, that's nice because if you use the quotient property, The quotient property allows you to take each individual log as one where you're doing the log base x of a, which is log base 3 of just the numerator 28, minus log base, same value there, 3 of 4. Of course, log base 3 of 28 is simply 3.0331, and log base 3 of 4 again is 1.2619. You may still need a calculator at the very end actually, but when it's all said and done, you didn't actually use the calculator's log functionality to get that particular answer. And yes, that's the final answer, roughly speaking. Moving on, part C. Log base 3 of 256. This particular question, 256, again, you don't see that embedded yet in 28 nor 4. However, you can technically consider that 4 to the 4th power ends up being 256. So you're really thinking outside of the box here with regards to using 4 and or 28 in context. Or this example B here with 28 and 4 with those two numbers dividing does work out well. Here you have to think a little bit more outside the box. 4 to the 4th is 256. The power property again applies just like it did back on part A, such that it's now 4 times log base 3 of 4. Again, the power property allows me to move the exponent in front as a multiplier. So now it becomes 4 times log base 3 of 4, and of course we already knew log base 3 of 4 was 1.2619, and then simply multiply. And again, you may need your calculator, but it does work out to be approximately 5.0476. So there are some questions that follow that are very much like what we just did. I do not plan on doing all of them, but I do want to uncover a few here. So let's take a look. Problems 1 and 3 might be worthwhile. As we can see, it does give us log base 12 of 3 is this decimal, and log base 12 of 7 is that decimal. So log base 12 of 21 shouldn't come as a big surprise, and I'll refresh our memories with the product, quotient, and power property from up above. In this particular case, 3 times 7, of course, is 21. So it may hopefully make sense that we're using the product property. Now what we're going to do with the expansion, so to speak, and that's really what this is, expansion of a singular log using the product property where we're going to be adding. So instead of log base 12 of 3 times 7, it splits into log base 12 of 3 plus log base 12 of 7. That is the expansion of, again, those two logs from the original singular log. Certainly this is easy where it's just 0.4421. This is easy as well, as you see 0.7831. Add the two, and if you need your calculator, fine, but in the end you didn't actually use the log functionality on the calculator, which is really the ultimate goal, I believe. Number 3, log base 12 of 49. Turns out, and I think it's a pretty nice connection to be made, and an easy one where you can rewrite 49 as 7 squared. Again, 49 is a perfect square, 7 squared fits the bill. Remembering now, because it's 7 squared, that power can be moved in front. Again, the power property allows for that. So now we have 2 times log base 12 of 7, which is 0.7831. And if we just move down here, we can see, if you multiply, of course, 1.5662. I do urge that you try those remaining 2 odds, 7 and 9. You could try 5 if you'd like later, but I have already done 7 and 9 for you to take a look at. 7 is more interesting. There's a little bit more nuance. All right, let me do 1 or 2 more and then have you guys also finish with this in the last little section on your own. Some questions. So similar to last problem there with log base, in this case now 5 of 3 is this, log base 5 of 4 is that decimal. I think we'll do number 12. So number 12, as you can see here, we've got log base 5 of 0.75, or as you can see, maybe better written as 3/4. Turns out you can use the quotient property to expand again, expanding as follows. Log base 5 of 3, the numerator, minus log base 5 of 4. So unlike the expansion on number 1 where we were adding using the product property, on number 12 we're expanding by virtue of the quotient property. Now it's just a matter of subtracting 0.6826 minus 0.8614. And of course, your decimal may be using your calculator if you so choose, which is fine. But the nice answer, as you can see, of negative 0.1788, you really did need a calculator to utilize from the functionality of a log or using a log. Never once really do you need to hit the log button on your calculator. All right, I am going to ask that you do those remaining 3 evens that I've highlighted already on your own. The answers are obviously there plus the work. Let's continue. So on the next page, I've used language of expanding, and technically there's also the language condensing that we have to take into account. Expanding means to make larger. Condensing means to make smaller. Okay, so solve each equation. We are going to use the properties of logs to solve. So similar to what we did in the prior page, but now look at this. We're going to solve 2 log base 3 of x minus log base 3 of 4, and that equals log base 3 of 25. So for our purposes, notably, please note that I've circled all of the bases. You really do need to start from that premise before you even attempt to apply the properties correctly. So if we continue this, we have 2 log base 3 of x, which I'm showing an arrow here depicting that I'm going to move that as an exponent. Next, the left side and the right side, particularly, we can continue, but only maybe what? Using the power property. And if you use the power property very specifically, it's log base 3 of x squared minus log base 3 of 4. And the fact of the matter is, now that we're going through after the power property, considering what? The subtraction of these 2 logs yields, using the quotient property, a condensing of these 2 as 1 log. In other words, if you're subtracting 2 logs with the same base, it's the same as dividing, in this case, x squared over 4. So log base 3 of x squared over 4, again, the quotient property. The right side I've denoted as, again, the same base. So the bases are the same, which is fantastic, as we may remember from a prior section, the property of equality, which allows us now to set x squared over 4 equal to 25. Now this is just an equation we can multiply both sides by to get 4 times 25. On the right side, of course, is 100, because 25 times 4 is that. And then I square root both sides after multiplication, and we end up with plus or minus 10. It turns out you absolutely need to check your answer with all log problems, as we've discussed in the past, particularly negative answers, where if you were to plug in negative 10 here, of course, you can't take the log of a negative nor 0. So crossing off negative 10 only provides us with the solution of which is 10. Since logs, again, are undefined for values less than 0, negative 10 is extraneous, as we've discussed. All right, part B. Similar type of thing. We've got log base 2 of x plus log base 2 of x plus 2 equals 3. So if we're going to solve this, the bases are the same, which I've circled. Do that, please, as well. And then you're going to go ahead and use the, well, as it turns out, the product property. I'm going to scroll down because the next step is just repeated here. The product property is, again, a matter of you bringing together, in this case, thanks to the plus sign, bringing together x and x plus 2. Because it's plus, we can multiply x and x plus 2. Now the right side of the equation is just a number. It's not an actual log of something. So that particular expression and equation can be rewritten from log to exponential form, where 2, as you can see, raised to the 3rd power, set equal, please, to x times the quantity x plus 2. So now the problem becomes a simple just solving of a quadratic, where you can distribute x squared plus 2x, therefore equals 8. We can balance such that it's set equal to 0, and then we can factor, and as you can hopefully see, x plus 4 and x minus 2 set each equal to 0, and you get negative 4 and positive 2, the 0 product property. But again, since logs are undefined as x less than 0, as we denoted earlier, negative 4 is extraneous. The only solution that works is 2. Please check all of your answers when solving log equations. And you don't necessarily even need to plug it in per se. You could even graph to check either part A or part B. And any type of solving of an equation can be checked essentially via graphing, as we've seen in the past. So please, please check your answer every single time.